Hello, my name is Dana Morse, and I am an educational technology consultant for Texas Instruments. In this video, we will be looking at the geometry features of the TI-Nspire CX family. I will be using the TI-Nspire CX2, but know that if you have a TI-Nspire CX, you should be able to do just about everything covered in this video. Let's get started by choosing number 1, New, and then let's choose number 3, Add Geometry. I know that I'm on a geometry application page because in the upper right hand corner there is a 1 centimeter scale. A great starting point is to go to Menu and select number 9, Settings. This is your Graphs and Geometry Settings page. I recommend using the Tab key to jump around from field to field. I'd like to point out this feature. The grid Lined grid allows CX2 users to have a lined grid always appear whenever they go to a graphs page. As you continue to press the Tab key, you'll scroll down to the additional options. I strongly encourage you to have Force Geometric Triangle Angles to Integers selected and Automatically Label Points selected. Please note that you use the click button, the center of the touchpad, to check or uncheck a box. Do not press the Enter button, as Enter does not check the box and simply selects OK. If you have what I have checked on your screen, we'll have the same experience. Press Tab, make sure that OK is selected, then press Enter. Now, let's go back to Menu. Let's select number 4, Points and Lines, and look at the submenu. Let's select number 1, Point. We can see in the upper left-hand corner that the Point tool is on. Your cursor becomes a pencil with a point attached to it. When you press Enter, it plots the point and labels it. To turn off the tool, we go over and press Escape. Now, as you approach the point with your cursor, notice that you could hover it with an open hand and it could say point A, or if you're on top of the label with the open hand, it says label. Sometimes it will say point A or label and also have a tab option. That means if you press the Tab key, you can alternate between what your cursor is hovering. This will make life so much easier as you don't have to have pinpoint accuracy with your mouse. To grab either the label or the point, you can press Control followed by the center click button where there appears to be a grab hand, and then as you swipe your finger on the touchpad, you can move whatever you grab within reason. The label can't get too far away from the point because that's what it's labeling. To let go, simply press Escape. If you hover the point and then press Control followed by the center click button, you can grab and move the point anywhere you wish on the screen. Again, let go by pressing Escape. Let's now go back to Menu, go back to number 4, Points and Lines, and this time let's choose line segment number 5. If you are ever unsure of how to use a tool, you can always hover the icon in the upper left-hand corner. Click 2 endpoint locations. All right, so I already have point A, so I'll click there once. And then as I move away, I can see that I'm constructing a line segment. To turn off your tool, simply press Escape. You can now manipulate line segment AB. When you hover the segment, it says segment AB. You could also go to point A. To grab, press Control followed by the center click button. To let go, press Escape. If we wanted to measure the length of AB, we'd go back to Menu. We would select number 6, Measurement, and because we want the length, we choose number 1, Length. We see the ruler icon in the upper left-hand corner, and we have two ways we could go about measuring. One, simply putting our cursor right on segment AB itself, and we can see in gray 11.2 centimeters. Or we could click on point A, and then click on point B, and we would get that same measurement. Notice as I move my cursor, 11.2 is stuck to my cursor. I can position it where I like, and then press Enter once more, and that measurement is now glued to segment AB. I turn off my measurement tool by pressing Escape. I could go to point A, grab it with Control-Click, and as I move point A, the measurement will change in real time. Press Escape to let go. Let's begin a brand new geometry page. Let's go Home. Let's select number 1, New Document. And let's select No to Do You Want to Save the Unsaved Document. Let's choose number 3, Add Geometry. Go to Menu. This time, let's explore Shapes, number 5. When I press 5, I see a submenu of all the different types of shapes we could create. Let's select number 2, Triangle. I see my triangle tool in the upper left-hand corner. My cursor has become that pencil again, and I'm going to click in 3 non-collinear points. 1, 2, 3. Now that cursor is still a pencil with the point attached because my tool, the triangle tool, is still on. Press Escape to turn off the tool. I want to clean up my triangle ABC. I do not care for the label A being inside the triangle, so I will hover label A, and my cursor says label. I'll press Control-Click, grab my label, and I'm going to reposition it outside the triangle. I press Escape to let go. Now I wish to measure the angles and the side length for this triangle ABC. I'll go to Menu. Measurement is number 6, and if I want to measure an angle, I'll select number 4, Angle. Now you cannot just hover a point and have it give you the angle. Instead, if I want the measure of angle A, I will first start at another point. Point C, I'll click on it. Then I'll go to point A, click on point A, and as I move to point B, I can see that I'm starting to measure the angle. When I click on point B, my angle measure for A now appears. I will repeat this process for angle B and angle C. Starting at A, I'll click once, then I'll click on B, then I'll move to point C and click on point C. Once more, B, C, A. My tool is still on until I press Escape. I want to clean up my triangle ABC with its angle measures, so I'm going to hover my angle measure that's on top of my label, press Control-Click, and I can reposition it inside the triangle so that now I have a much prettier picture to look at. Next, I want to find the length of each side of triangle ABC. I'll go back to Menu, I'll go back to number 6, Measurement, and I'll select number 1, Length. Again, there's my ruler icon in the upper left-hand corner. If I wanted to find the length of side AC, I would hover AC, but no, it doesn't say segment or side AC. It says triangle ABC, which means if I were to click right now, I'd be finding the perimeter of triangle ABC. See the tab at the side of triangle ABC? If I press the tab key, it now says side, meaning I will only find the length of side AC. If I press enter once, I have found that measurement and it is stuck to my cursor. I can position it where I want and press enter again. I will repeat this for side AB. Initially, it wants to find the perimeter. Press the tab key, press enter, and then position it where you want it to be and press enter again. Once more for side BC, hover, tab, press enter once, position it where you like, press enter again. When you have found all three side lengths, go ahead and press escape to turn off the tool. The TI-Nspire CX family offers dynamic geometry software. In a nutshell, when you go to point A, B, or C, you can grab that point, Control-click, and in real time, you can explore the angle measures, the side lengths, all the features of this triangle by grabbing and moving. Spice up your triangle. Go and hover the side of triangle ABC. Press Control Menu. Control followed by Menu is the equivalent of a right click on a computer. Letter B has Color, and you can choose number 2, Fill Color. Here are color options where you could add a little spice to your geometry page. I chose yellow. I click off in the white area, and now I have a much prettier, much more dynamic picture to look at. I'm curious about the area of triangle ABC. So if I go to Menu, and I go back to number 6, Measurement, and I select number 2, Area, I see the Area tool in the upper left-hand corner. I'm going to hover triangle ABC. I see it says triangle ABC, and I see centimeters squared, which I know means it's the measurement of an area. I'll click once or press enter, and that measurement is stuck to my cursor. I'm going to position it up here out of the way. I'll press enter again. I'm going to turn off the tool by pressing escape. If I were to find the midpoints of all three sides and created a triangle based off of those midpoints, I'm curious how the area of that smaller triangle would compare to the area of the larger triangle. To do this, let's press Menu. Let's choose number 7, Construction, and midpoint is number 5. I see the midpoint tool in the upper left-hand corner, and I can just hover the three sides. I hover AC. I'm nowhere near the midpoint, but I can see that midpoint pop up. I press enter, and that point stays on side AC. I repeat for side AB and for side BC. I have 3 points to make my triangle. I can go back to Menu, back to number 5, Shapes, and then select number 2, Triangle. I will create a triangle connecting my 3 midpoints. Click, click, click. I now want to go back to Menu, back to number 6, measurement, and select number 2, area. I will hover the inner triangle, click once, and move that measurement up near where I positioned my first measurement. I press Escape to turn off the tool. I can see that the larger triangle is 4 times greater in area than my smaller triangle. Let's make that smaller triangle have some character. I'm going to hover that triangle, Control menu on the handheld or a right click on your computer, letter B for color, number 2, fill color, and I'm going to fill that one with Dodger blue, and then I'll click someplace off, and I can see my 2 triangles. Let's add a new geometry page. Press Control followed by Dock, because just above Dock it says Add Page. Let's choose number 3, Add Geometry. We are now on Problem 1, Page 2. If I wish to go back, I can either click on the tab at the top for Problem 1, Page 1, or I can advance by pressing Control and the direction I wish to go using the touchpad. Control left goes back a page, Control right goes forward a page. Let's go to Menu. Let's choose number 4, Points and Lines, and then in there, let's select number 6, Ray. The Ray tool is active, you can see in the upper left-hand corner. I'll click once to drop a point, and then I'll click again to make my ray. I'm going to go back to that first point, click once, and then click again so that I have 2 rays starting from the same endpoint. I'll press Escape to turn off the ray tool. I wish to measure the angle formed by these 2 rays. I'll go to Menu, I'll select number 6, Measurement, and I'll select number 4, Angle. I see my Angle tool selected. I'll put a point on my ray. I'll click the point where the 2 rays start from, and then I'll click again on the other ray. And I can see my angle measurement. I'll press Escape to turn off the angle measurement tool. I now wish to construct an angle bisector. So let's go to Menu. Let's go to number 7, Construction, and an angle bisector is number 4. The angle bisector tool is selected. I'll press Enter on point B. I'll press Enter on the point that both rays share, and I'll press Enter on point A. I have now created an angle bisector. I'll press Escape to turn off the tool. An angle bisector divides an angle into 2 congruent angles. So I can go to Menu, number 6, Measurement, and use number 4, Angle Measure, to measure my 2 new angles. Press Escape to turn off the tool. They all seem to be laying right on top of one another. I can grab and move and see that it truly divided my angle into 2 congruent angles. Let's add another geometry page. Press Control, Dock to add page. Number 3, add geometry. And let's explore circles. Press Menu, number 5, Shapes, number 1, Circle. Upper left-hand corner has the icon of our circle tool. This one requires 2 clicks. 1 click to drop the center point, and as you move away, press click or enter again to create your circle. Press Escape to turn off your circle tool. Let's now explore the circle a little bit. Press Menu. Let's select number 4, Points and Lines. And let's select number 7, Tangent. The Tangent tool is selected. Move to the circumference of the circle and click on the circle. Click once more, and you have now created a tangent to your circle. Press Escape to turn off the Tangent tool. Let's look at the slope of our tangent as it moves around our circle. Press Menu, select number 6, Measurement, number 3, Slope. Slope tool is active. Hover our tangent line. Click once to select the measurement of the tangent line. Press Enter again to position where you would like that measurement to be. Press Escape to turn off the Slope tool. Now position your cursor on point A. Grab point A by pressing Ctrl followed by the click button, and as you swipe your finger on the touchpad, you can see the slope changing as you move around the circumference of the circle. Just another cool feature in the geometry application on the TI-Nspire. Press Escape to let go. You definitely will want to play with the geometry application on the TI-Nspire. However, as many teachers say, we don't want to reinvent the wheel. A lot of activities are already made for you on the TI website. TI's website is education.ti.com. Here you will find a plethora of free resources to use in your classroom. I recommend hovering the Activities tab, and you can find Math Inspired in the Activities tab. Math Inspired breaks down courses from middle grades math all the way through calculus and statistics. I want to demonstrate an example lesson from middle grades geometry and high school geometry. So I will start by clicking on middle grades math. I see in middle grades math geometry. Here I have lessons, activities aligned to state standards and textbooks for teachers to use in their classrooms with students. I particularly like the reflections and rotations lesson found in Math Inspired. I can click on reflections and rotations, and now I get a mini video where I can see what is covered in this activity. Click on the play button and you will see the lesson in action. Over here on the right-hand side, you can see the handouts for this activity. There are 2 student activity handouts, one in Word format so that a teacher can make changes if they wish, one in PDF format if they like the way the activity is set up. There's also teacher notes in a PDF so the teachers know exactly what questions to ask and an answer key is provided. The TI-Nspire activity, TNS, is the file that you would actually use on the handheld and software. Now we know when you go off to the internet to find activities, we can get sidetracked with YouTube and other distractions. So I like to point out, back in the software, there's a tab at the top that says Content. Math Inspired is a link in the software itself. If I go to Topic and make it Geometry, and then go to Category and select Geometry, the lesson we were just talking about, reflections and rotations, is right there, and here are my activities that I was just describing. I can double-click Reflections and Rotations TNS, and it opens up the activity right in the software. I went ahead and opened up the student activity that follows along the TNS file for reflections and rotations to give you an idea of the student handout that assists in the lesson. Page by page, giving students prompts to observe what happens when you reflect and rotate as it outlines in the activity. The teacher notes for the reflections and rotations activity outlines what you should expect throughout the lesson. It gives you discussion points and answers that would go along with the student handout. Let's go through the reflections and rotations activity. Press Control, right arrow to navigate to the second page. The directions say to reflect over the x-axis. We see triangle ABC, and down at the bottom I see a slider. When I click on the slider, I now see A prime, B prime, C prime, the reflection of the pre-image triangle ABC. Any good geometry teacher would want to know the coordinates for triangle ABC and triangle A prime, B prime, C prime. So I would go to Menu, I'd select number 1, Actions, and the 8th item on that menu is Coordinates and Equations. In the upper left-hand corner, I see the Coordinates and Equations tool. I can now hover, click once, position it where I like, click again. For A, B, and C, and repeat this process for A prime, B prime, and C prime. Press Escape to turn off the tool. It appears that when you reflect in the x-axis, the coordinates xy map to x, negative y. Remember me saying that the TI-Nspire has dynamic geometry software? If I go to the pre-image and I grab point C at 2, 3, I can move my pre-image, and as I move, my image, the reflection, changes in real time. That is a wow factor. Advance to 1.3 by pressing Control, right arrow. Now we have triangle DEF, and it's asking to reflect over the y-axis. We click on our slider tool, and we now have triangle D prime, E prime, F prime. Find your coordinates again by pressing Menu, number 1, Actions, number 8, Coordinates and Equations. Click twice, once to identify the point you wish to label, and the other one to position it. Repeat this for your image. Press Escape to turn off the tool, and we can see a reflection in the y-axis takes xy and makes it negative xy. Control right arrow will take us to 2.1. Now we're talking about rotations. Rotation about the origin 90 degrees. I will move my cursor over to the little clicker slider. I'll click, and I can now see the shape of ABCD rotated 90 degrees about the origin to create A prime, B prime, C prime, D prime. To get a mapping rule for rotations about the origin 90 degrees, I'll press Menu, select number 1, Actions, select number 8, Coordinates and Equations. I'll hover A, click on it once, position the coordinate 7, 11. I'll go to A prime, click on it once, position it, and I now am at negative 11, 7. It appears that x, y maps to negative y, x. Let's see if that holds true for another coordinate. I'll go to C, click on it once, position it, press enter, 14, 4. If I am correct, this should be negative 4, 14. Math is magical. Let's advance. Control, right arrow, 2.2. We are now going to rotate this object 180 degrees about the origin. When I click, I now see the image of my pre-image rotated 180 degrees about the origin. Let's get some coordinates. Menu, Actions, Coordinates and Equations. I will go to point F, click on it once, click to position it, F prime, click once, click again to position it, 10, 13 becomes negative 10, negative 13, so xy maps to negative x, negative y. 14, 3 for G should be negative 14, negative 3 for G prime. Control, right arrow to advance to the next page, a rotation about the origin 270 degrees. I'll position my cursor on top of the clicker. I'll click once, and I now see a rotation about the origin 270 degrees. To get the coordinates for the mapping rule, I'll press Menu, Actions, number 8, Coordinates and Equations. I'll go to K, find that it's at 6, 12, K prime, 12, negative 6. I'll do the same for M, 3, 4, M prime, 4, negative 3. X, Y maps to Y, negative X when you rotate 270 degrees about the origin. Let's advance to the next page, press Control followed by the right side of the touchpad, and we can now see a reflection already taking place over the line Y equals X. We can grab F, and as you move, you can see the reflection move in real time. This is truly dynamic geometry software. But wait, there's more. Press Control, right arrow, and you now see that we're going to rotate this object about the origin. The pre-image is the gray F. The image would be the blue F. It's already been rotated 90 degrees counterclockwise. I can go up here to this little white hollowed out circle, grab it, and as I move, I can see a rotation counterclockwise about the origin. If I go down to this little clicker, it changes it to clockwise. And I'll repeat the process, grabbing so I can see a counterclockwise and clockwise rotation about the origin. What about a rotation but not about the origin? Press Control right arrow, and now we can rotate about point P. The beauty of this page is that you can grab point P and reposition it. So now we are rotating this pre-image about point P 90 degrees. P can be moved, and we can also change counterclockwise or clockwise about point P. Let's go back to our Content tab. We're already in Math Inspired. The topic will be geometry. Let's make the category circles. And let's select secants, tangents, arcs. In the bottom right, I see the TNS file, the student handouts, and the teacher notes. I will double-click the secant, tangents, arcs TNS file, and it will open up in the software. If you wanted to transfer this activity to your students' handhelds, there are two ways about doing it. One, if you have connected handhelds, either with the computer USB to mini USB or handhelds in the TI-Nspire CX docking station, you can go up to Tools, select Transfer Tool, and you could select this activity to be transferred to the connected handhelds. The alternative way, if you have TI-Nspire CX Navigator, you could send this file to all of the students currently logged into class. Let's advance to page 1.2. Control right arrow, and here we have the breakdown of a circle. We see the minor arc is going to be shown in the orange, and the major arc is going to be shown in blue. Minor arc is less than 180. Major arc is greater than 180. As I grab point A, I can move it along the circumference of the circle. This little activity can help students visualize the difference between a minor arc and a major arc. Let's press Control right arrow to advance to page 2.1. There's a lot going on page 2.1. It appears that we have two secants intersecting at point P for circle O. We see at the bottom the measure of angle APB. We see the measure of the arc AB, and we see the measure of the arc CD. You can grab point P and reposition it anywhere inside and on or outside the circle for students to see the relationship created with circle geometry. So a central angle is an angle formed when the chords or secants intersect at the center of the circle. We can see that the angle measure is equal to the intercepted arcs. grab point P and move it inside the circle, not at the center and not on the circle, and you can see that the angle formed is half the sum of the intercepted arcs. If point P is moved on the circle, the angle is an inscribed angle, and it's equal to 1/2 of the intercepted arc. Something cool about this activity is that point P isn't the only point that you can move. I could go to point Q, and I can change point Q, and you can see that it's still equal to 1/2 the intercepted arc. If point P happens to be outside the circle, now it's the larger arc minus the smaller arc divided by 2. You can play around so that you can see a nice representation. 130 minus 50 is 80. 80 divided by 2 is 40. Currently, we have 2 secants, but in circle geometry, we could have a tangent and a secant. Here is our tangent and a secant representation. 200 minus 93 is 107. 107 divided by 2 is 53.5. I could make this 2 tangents. Now, 239 minus 121 divided by 2 is 59. As before, you can go back to the Content tab and you can download the student and teacher notes for this activity. Here you see both the student activity and the teacher notes for the secant, tangents, arcs lesson. Students can go step by step with the TNS file, and the teacher knows exactly what questions to ask, what to expect, and quick pull options if you have the TI-Nspire Navigator system. Let's go ahead and go back to Home and choose number 1, New, and we'll say no to saving changes before exiting. Now, let's discuss assessments. Some states have an end-of-course exam for geometry. Very few allow those questions to be used by the teachers to help prepare for next year's exam. New York State has the New York State Regents exam. The New York State Regents exam, after administered in January, June, and August each year, becomes public domain. The website jmap.org houses all of the old Regents exams for New York State dating back to the 1800s. As you explore the website, you'll notice hyperlinks all throughout the page. There are resources by standard, resources by topic, and even Regents exams to go through where you have a bank of questions to use with your TI-Nspire handhelds and maybe TI-Nspire CX Navigator system. If I were to select resources by standard geometry and then to select verify experimentally the properties of a dilation given the center and the scale factor, I find a worksheet link, and TNS is the file for the TI-Nspire technology. I will select the TNS file, download it to my computer, and open it up within the Nspire software. I have downloaded the file. I'm back to my software. I'm going to open a document. I'm going to select the file I just downloaded from the JMAP website, click Open, and now I'm going to go to the page Sorter View, and I can see Regents exam questions all on this standard. These questions could be sent to handhelds that are hardwired to your computer or connected in the docking station or pushed as a quick poll using TI-Nspire Navigator. One really nice feature about using these resources from jmap.org is that the answers are built in. So when a student answers their question, it will check the student's answer with the correct answer that's running in the background and instantly grade it for the teacher. You could then save your results into the portfolio where you'll have a grade book for all assessments run in your classroom. I'll go back to my Documents tab, go back to the calculator interface, and then I'm going to go back to jmap.org. I'll back out and go to Regents exams. Now I can find Regents exams for geometry for the months of January, June, and August for years 2020 dating back to 2008 for the TI-Nspire technology. Simply look for TNS files for the month and year that you wish to use. This happens to be the January 2015 geometry exam. Going back to the page sorter view, I can now see questions that were asked on that year's geometry Regents exam. I can select any one of these questions and I could send it to the student's handhelds, either wired to the computer, through the docking station, or through Navigator. Over the course of this video, we went over the geometry app basics, we explored geometry, we did some hands-on with some sample activities, reflections and rotations, we explored secants, tangents, arcs, and even looked at assessment resources using jmap.org. If you are somewhat new to the TI-Nspire CX technology, one of the resources I've made is my Getting Started Guide for the TI-Nspire CX. It breaks down every single button on the handheld and shows menus in the software so that you can find what you're looking for. There's hotkey commands, also how to navigate. All the menus are shown, gives you tips, shows the applications, goes all the way through the different features of the TI-Nspire CX technology and offers links for video tutorials and support. If you are interested in receiving that or have any questions in regards to this video, please feel free to contact me at dmorse@ti.com. You can visit TI's website at education.ti.com. Follow us on all the social media platforms at TI Calculators. Be sure to like us on Facebook, Texas Instruments Education. If you happen to enjoy this video and would like to see more videos, I have a YouTube channel. You can search for Mr. Dana Morse, and I have videos on both the TI-Nspire and TI-84 platform in all sorts of topics ranging from algebra through calculus, coding, robotics. Please feel free to visit and use any of these videos that you can benefit from in the classroom. Thank you for your time. I hope you enjoyed this video.